Okay, let's do problem 116, populating next right pointers in each node. So here we're given a perfect binary tree where all the leaves are on the same level and every parent has 2 children. And if you look at the definition of node, we have our usual the value and 2 pointers to the left and right. So that would be this node has a value of 1 and it has left node of 2 and then left right node of 3. But this has additional pointer next, so it points to the one on the right side of its node. So when we look at 2, it has left and right pointer, but it also has next pointer that points to 3. So initially all the pointers are set to null. And this is the setup we have, and then we have to fix our next pointer. We need to fix these 4 and we need to leave these 5, these 3. The reason this don't need to change is there isn't any node next to them, so their next pointer should be null. So that's why when we look at the output for 1, 3, and 7, after them they have hash, which means they have null next pointer. So how should we solve this? Well, it would make sense to think that we have to apply next pointer level by level. But say we are at this level here and then we want to establish next pointer for this, so that 2 points to 3. But is it possible, as in, can this 2 know what 3 is? The answer is no. But when we look at this level here, 1 actually has information about 2 using left pointer, and it also has information about 3 using the right pointer. Hence we can establish a next pointer. And 1, because which is the root, it doesn't have any next pointer, so we don't need to touch on it. So the logic is when we are at one level, we work out the next pointers for the next level, and then when we are at this level, we work out pointers for the one after. So let's write down the logic. So it would be we are going to initially set this to level ahead. So it would be node level head is equal to root, and then while level head dot left is not equal to null, we are going to work out the next pointers for the one below. And the reason I set left is because next pointer points to the one on the right, so we should refer to these so that we can define the next pointers. And then for each iteration, we're going to do level head dot is equal to level head dot left. And let's work out the case for the first level. So we can simply do level head dot left dot next is equal to level head dot right. So level head dot left dot next is level head dot right. That's fine. So we establish next pointer. And we move the level head down by 1. And if we do the same thing, we only establish left head for this. So how can we work out this next pointer? So we can actually use this previously established next pointer. So we can check if this pointer has next. This left head's right should point to level head's next dot left. So we can say if level head dot next is not null. Level head dot right dot next is equal to level head dot next dot left. So we establish next pointer for this. So for this node, we have established next pointer for 2 children. But what about this one? We also need to establish these 2 next pointers. So our base logic is correct, but there should be some recursion to it. So we can do for node car equals level head, and car. So what's the logic when car is not equal to null? We do car is equal to car dot next. So essentially we worked out 2 pointers for this, and then we do need to iteratively work out 2 next pointers for the next node. So far we have only done this, and then if we put them into iteration, this will become car, and then we will do the same thing. So this logic will go inside here. And then we do need to change the names of the variables. So this should be car like this. And then we return root. We need to address one edge case. If root is equal to null, we return null. Okay, let's submit. All right, that's it.